When you think of a graduate-level algebra textbook, what comes to mind? Probably a brick of a book, right? Just packed with dense formulas and super dry theorems. But what if I told you that hidden inside the preface of one of the most famous algebra books out there is this deeply human blueprint for how to think, teach, and learn? Well, today, that's what we're doing. We're going to find the soul inside Michael Artin's classic text, Algebra.
So what even is the soul of a textbook? I mean, is it just a collection of proofs and problem sets, or is it something more? Is it the author's voice, their philosophy, their unique way of guiding you from being completely lost to finally understanding? For Artin, it's absolutely the second one.
Okay, so where do we start to find this soul? Well, lucky for us, Artin lays it all out in what he calls his guiding principles. And this isn't just some boring list of topics. It's basically a mission statement for the entire book. I just love this quote. Right off the bat, you get a feel for his tone. It's so candid, maybe a little self-deprecating, and just incredibly down-to-earth. He's not hiding behind a bunch of academic jargon. He's telling us straight up, here's what I'm trying to do, even if he thinks it sounds a little obvious.
And here is his number one principle. Artin's goal isn't to just teach abstract algebra in a vacuum. No way. He wants to show you why it actually matters. By connecting it to something like geometry from page 1, showing how a simple equation can describe a perfect circle, he makes it so clear that algebra is this powerful tool for describing the world around us. And that's a game changer, especially for students coming in from physics or engineering.
So you might be asking, how does this philosophy actually change how the book is put together? Well, let's just say he pretty much throws the traditional playbook right out the window.
Just take a look at this structure. Most algebra courses follow this really standard path. Groups, then rings, then fields. But Artin, he flips that whole thing on its head. He kicks off with the more visual stuff, linear algebra and geometry, then he brings in group theory. But then, and this is the really radical part, he makes you wait all the way until chapter 11 to get to rings.
So why on earth would he do that? It's all about building your intuition. He wants students to see algebra working, to get their hands dirty with real, concrete examples from geometry and matrices before they hit the really heavy abstract stuff like ring theory. It's a classic show, then tell approach, and it works.
And that brings us to his direct advice for teachers. And let me tell you, he does not mince words here. He has a very, very strong vision for how this book should actually be used in a classroom setting. This quote just perfectly sums up his whole point of view. He's basically saying, hey, don't just teach the syllabus. You need to spark some curiosity. The whole point isn't to just check off boxes and cover every single chapter. It's about exploring the fun, interesting corners of the subject. And he even says, if that's not your style, then this probably isn't the book for you. I mean, how bold is that? Now, every single field has one of these, right? That one concept that is just notoriously difficult to teach and even harder to learn. Well, in abstract algebra, one of the biggest ones is the idea of a quotient group. Let's try to think of it this way. Imagine you have all the integers, every single one. A quotient group is kind of like saying, I don't care about the specific number. I only care if it's even or odd. You're basically lumping together all the even numbers into one big bucket and all the odd numbers into another. See? You've just simplified this huge infinite group into just two simple categories. The problem is, the formal way you construct this for more complicated groups can feel like a totally unmotivated magic trick. And you know what? Artin totally agrees. He comes right out and says it's a pedagogical problem. He's validating the struggle. He gets that the standard way of teaching this is just plain hard for students to wrap their heads around. So what's his big solution? He tells teachers to just forget the abstract construction for a while. Seriously. Instead, he says, show students how a quotient group is the result of a special function, a map, between two other groups. Think of it like a projection. If you have a 3D object and you shine a light on it, its shadow on the wall is a 2D projection. That shadow is the image. It's a simpler version of the original. And that is a much, much more intuitive way for students to grasp the idea at first.
And this attitude, this desire to make things understandable, it extends to other really tough topics. When he was trying to decide whether to include the advanced topic of group representations, his reasoning was just so simple and brilliant. He said, if chemists, who use this stuff all the time for things like spectroscopy, can teach it to their students, then why can't we? It's a call to make math accessible, not to be a gatekeeper.
But this preface isn't just a guide on how to teach. It's also this incredibly human document that kind of pulls back the curtain on how knowledge actually gets made. And it's not a solo act. He thanks a whole village of people. We're talking mentors, reviewers, editors, and especially his students. It completely shatters that myth of the lone genius scribbling away in isolation. This book was a massive community effort, refined over 8 years of him manually retyping manuscripts, by the way. This was long before he even owned a personal computer. He even gives these special shout-outs to his colleagues, noting that he talks with them often about everything. That's not just professional courtesy. That's a beautiful nod to the friendships and the intellectual partnerships that really fuel academic life.
And then, tucked away at the very end of all the acknowledgments, is this absolute gem. This small, private moment with his child, correcting his counting. It's so disarming and charming, and it's a peek into the real life that's happening just off the pages of all this dense mathematics. It's a wonderful reminder that these huge, monumental works are created by actual people with real families.
So let's step back. Why does a preface, written decades ago for a super advanced math textbook, still matter so much to us today?
It matters because this is about way more than just algebra. Artin's preface is really a masterclass in pedagogy. It's about having a clear philosophy, about designing a structure that actually serves the student, and about communicating with honesty and, well, with humanity. It's a lesson in how to teach with intention and empathy.
And it leaves us with this really powerful question to think about. What if every teacher in every subject laid out their blueprint for learning just like this? Imagine if every course you ever took started not with just a syllabus, but with its soul.